I have a simulator at home. I love driving. And every time I'm like, damn, it would be so cool to drive a remote control car with my simulator. And I saw a guy try to do it. He used some FPV drone ports. But yeah, I think I can do better. So this is my take on this. It will be a 3-part series. The first one will be about the software, and this one. Then I will do a video about the electronic, and a last video about the mechanical. I will try to 3D print everything and not use tools too complicated, just to make sure everybody can do it at home if they want to. So yeah, maybe if everything goes right, there will be a last video on which I will give you all the code, all the parts of all the software, everything, so you can do it at home. And if you also have a simulator, you will be able to control your car from your simulator. So let's start. Let's start by understanding what we are dealing with. This is a Raspberry Pi 5, and it will be the center of our remote control car. It will communicate with our PC that will be connected to a steering wheel via a socket. We will get on that later. The software will take the info from the steering wheel, send it back, and also feed the steering wheel with the info about the force feedback. I will get on that in a couple of seconds. Now, this Raspberry Pi gets the info from the steering wheel, and it will send it back to this ESP32 that will control the motor, the servo motor, and the load cell. As I said, we need something to get the force feedback. So the load cell will be there to feel the force applied on the wheel, and will send it back on the software that controls the steering wheel and feed it back to the user. Now we still need to understand how to do some video feed. I still don't really know how to do it because it's a bit complicated. But I was thinking about using some software to encode it and send it on the software that is on the PC, and use VLC, well, the library of VLC lib, to display the image on our software. Unfortunately, I don't know how will be the latency, so we will see when I get it and we can do some testing. For now, we will work on the software between the Raspberry Pi and the PC. The rest will be for later. So we need to install an OS on the Raspberry Pi. To do this, you will need a micro SD card that you connect to a dongle. It can be one thing like that or like that. You will connect it to a PC that has the Raspberry Pi imager installed. You will launch the program, select what kind of Raspberry Pi do you have, then you will select which OS do you want to have. We will use a Ubuntu server, and then you will select obviously the media in which you will want to install. We will add a couple more settings. You will need to put a username, a password, the Wi-Fi name, and the Wi-Fi password. The last thing to do is just to activate SSH so we can connect to it. To connect to it, you need to take the Raspberry Pi, connect it to the power using this, and it will start alone. Now you go on your PC, open a Windows command, and you will type SSH with a space, and then the username that you used, and finally the IP address. You can use an app like Net Analyzer to find the IP address of the device that are connected, or connect to your router and just watch what device are connected, and you just copy the IP address of the Raspberry Pi. Once you've done that, you press enter and you will be in your Raspberry Pi, and you can start to put things on it. Now we need to start programming the system to communicate. We will use two sockets. One socket to receive and one to send. And they will be independent on two different threads, so we will use thread to separate the workload. Why do we use a thread? Well, a thread is useful because we can use some resource and wait for something without stopping the whole program. When we use the receive function, the program will stop and wait for the data to arrive. But if we stop the program, we lose performance. So we put it in a thread, so the thread stop and wait for the data. We will then pass the data between the different threads using atomic variables that can be used to pass data between different threads without causing problem. Because if you access at the same time the same data and modify it, you could have a race condition and have some problem in your program. So we will use atomic variables to not have any kind of problem. So let's see how we will build this thing. On both hands, we will have a main thread and two separate threads, one to receive the data, one to send the data. The Raspberry Pi will send the data about the force feedback and the PC about the wheel. And the main thread on the PC will manage the GUI and the wheel, while on the Raspberry Pi it will manage the connection with the microcontroller to connect to the motor and everything else. So that's the basic idea. Now let's make everything work. I finally finished program everything. So what did I do? For the app, I use Win32, which is the native API from Windows to make app. Right now there isn't anything on it, but at the end, in the final version, I want a camera player to see where the car is going in real time. I didn't implement it yet for a reason that I will explain later. But right now in the app, what there is something to take the data from the wheel and the pedal, obviously. I use the Logitech SDK to do that and send it to the Raspberry Pi via a UDP packet. I didn't use TCP because I care about latency and performance, but I don't care about reliability of the packet, because at the end I will always send new data every 30 milliseconds if I remember correctly. So if I lose a packet, it isn't that big of a deal. Now that the data is on the Raspberry Pi, what happened? The Raspberry Pi will send back some data to the PC, mainly the force feedback, but also an indicator for battery. I didn't implement it yet totally, because I didn't find the electronic pieces that I wanted to do it, but if one day I'm able to do it, it's already implemented. So now that's talked about, let's talk about the big elephant in the room, the camera. It's probably the hardest things to do, because you want low latency, but it's also computationally expensive and it takes a lot of bandwidth. I wanted to use a technology that I found, but I didn't make it work. I wasn't able. So I end up using MediaMTX, which can create a WebRTC server, and I have approximately like 200 milliseconds of latency, something like that, which is significant but manageable, at least I think. We will see when the prototype is put together. So yeah, simply it starts a server, you can connect to it. I didn't put the player because I found another way to do the camera, which is less expensive, more reliable, with lower latency, but it's a bit harder to do, and yeah, I will do it probably on the next iteration. So I won't be making a WebRTC player on the app just to change everything later. So right now the app just open a web browser on the URL of the Raspberry Pi, and you can see from there the camera, which is functional. It isn't ideal, but it works. So good enough for me. On the next iteration we will do something better. But yeah, that's pretty much everything I used. So Win32 for the UI, then I use Logitech software development kits to get the data from the steering wheel. I didn't use the Microsoft API just because I didn't understand how to do it. Yeah, skill issues on my ports, but the Logitech API just works, so thank you Logitech. And yeah, then we send everything on UDP using some struct with the data back and forth. And for the video I use MediaMTX on WebRTC protocol, and everything is displayed in a web browser, which everyone has. So yeah, everything is now working on the program side, but we still need to do the electrical component and the mechanical part, which will be each in another video. So subscribe if you like and if you're interested, and if you have anything to say in the comment, I will read everything. So see you next time.